today we're going to go over how to solve rational expressions. A lot of students seem to have issues with these types of problems. So we're going to go over, just in this video, one method in order to solve these. In another video, we'll go over another method because there's more than one way to solve these types of problems. And whichever method you are more comfortable with, that is the method that you should continue with. So let's start with a couple of basic problems. For example, number 12 and number 14. I'm going to rewrite number 12. And as I rewrite it, I want you guys to slowly start thinking about what the common denominator is. When we are solving these types of equations, what we need is a common denominator. A common denominator is like the least common multiple, but it's the least common denominator. So we'll go to the side, least common denominator, and try and find what they are. I see one is a t, and there's a one that on its own that's t minus 2, and another denominator that is t. So as we can see, when it comes to variables, the least common denominator would be 1t multiplied by the t minus 2. Those two parts together create my least common denominator. At this point, we have pretty much broken the code. All of the hard stuff is going to go away now. So we need to make sure that we really understand how to solve for the least common denominator. So now that we have the least common denominator, I multiply everything by the least common denominator. Now, you don't have to put it all on top like I am. Some students prefer to multiply the whole thing like this. I do not like doing that. I like to see and cross cancel. Now, we cancel, if we can, anything from that multiplication of the least common denominator and the current denominator we are multiplying to. I can see in this situation that the t on the denominator and the t on the least common denominator will cancel. I continue to the next one. The same thing happens. Those two t's will cancel. We look at all the way on the left, and t minus 2 should cancel with t minus 2. At this point, all I'm going to do is multiply the numerator with whatever did not get canceled with the least common denominator. So we do 50 times t. Keep the sign, 16, keep parentheses, t minus 2. Equals, keep the numerator, and then multiply with the least common denominator. Sometimes it is easier to make sure you keep your parentheses so the parts, and we don't, jump into the distribution. Sometimes it's easier to write these out. In fact, I strongly suggest it. Write it out, and then we can distribute. So let us now clean up the next step. 50t minus 16t plus 32 is equal to 30t minus 60. Now we're just going to combine like terms. That is it. That's all we're going to do moving forward. 50 minus 16 is 34t. I'm going to subtract the 32 to the other side. 34t is equal to 30t minus 92. Now this should all slowly make sense because now we're just doing basic multi-step algebra. All of the canceling has made this into a normal math problem that we are very much used to. We will subtract the 30t over. 4t is equal to negative 92. Now we have to just make sure we fully solve this out. Negative 23. Now, we need to make sure we write our restrictions. This solves the equation. However, we need to have restrictions. You are not allowed to have a 0 in the denominator. So what does that mean? I have to set each denominator to not equal 0 to make sure we do not have any points on our domain where t is not allowed to be. We clearly see from the left side, t cannot be 0. And if I add a 2 over, we clearly see that the right side cannot be 2. So we'll clean it up where we'll write our final answer as t is equal to negative 23, where t cannot equal 0 and 2. That will be my final answer. Cool. Any questions with that? Just please write it in the comments and I will more than happy make another video responding to them. Okay, cool. Next, number 14. In this one, we clearly see that we are not fully factored on all of our denominators. We must be fully factored on all denominators. That way, we will actually be able to make sure we are finding the correct least common multiple. Let's make sure we put that there. So our least common denominator, let's move this guy over a little bit actually. Our least common denominator is, wait, again, not fully factored. So fully factored, yes. Can this factor anymore? No. So fully factored, yes. Fully factored, no. Why? Well, there's a GCF. What is the GCF? I can pull an X out. And now we can write our least common denominator. And our least common denominator will be, again, the combination of all of the denominators. There's an X, but I don't need to include it twice. So just one X. There's an X plus 2, but I don't need to include it twice. X plus 2. My least common denominator is X times X plus 2. Now, in this situation, again, I always advise in kind of a cleanup step, if you had to factor anything, it is better to be organized than fast, because organized always gets it correct. We will then now multiply. Let's make sure this goes this. It's kind of ugly. Let's just bring it here. Oop, kind of ugly again. Sorry. And boom, that's better. So we are now going to multiply everything, every term, by that least common denominator. And then we will cancel what we can cancel. The X will cancel with the X. The X plus 2 will cancel with the X plus 2. We will write what is left, just a numerator, nothing left from the least common denominator. All of that was canceled. Let's move on to the next one. X plus 2 cancels with X plus 2. I need to write what's left. What is left? I see an X numerator times one of the least common denominators of an X. There we go. Again, we continue. Cancel. Oh, that's not red. Let's try that again. Cancel the X's. What do we see? We see a 3 from the numerator multiplied by the least common denominator remaining, plus we have our equation. There is no more complications. We are doing algebra. Distribute your 3. Multiply the X's. And look, we're going to have a quadratic, which means we're most likely going to have to factor now. If we see an X squared and a quadratic form of, like, if we can recall, AX plus BY equals C, right? Or AX squared plus BX plus C equals 0. This would be the standard form of linear. As we can tell, there's no exponents, right? As you can see here, that X squared is what pretty much is my key to tell me that we are quadratic. So now that we know we're a quadratic, we can see AX squared plus BX plus C equals 0. So we're going to move everything over. X squared plus 3x, subtract the 4 plus 2. All we need to do now is use our X method we have learned in the previous video. A times C goes on top, B goes on bottom, over X, find factors of 2 that will add and subtract to 3, positive 2, positive 1, 1 plus 2 is 3, 1 times 2 is 2. Rewrite denominator keep sign numerator, denominator, keep sign numerator, and we have that set equal to 0. After that, we do know that all we got to do is separate, set equal to 0, separate, set equal to 0, and individually solve them to a point where we see x is equal to -1 and -2. Now, we are not done just yet. We need to double check that our restrictions have not been broken. And if they have, we have to take out that answer. Well, I guess I have to get rid of this. I did not do that well. Yeah, let me try that. Switch. Let's try that one more time. Okay. So now that we have x is equal to -1, x is equal to -2, remember, I cannot be equal to anything that creates a 0 on the denominator. I take my denominator separately from the beginning. X equals 0, x plus 2 equals 0. Your least common denominator, set that guy to equal to 0 individually. We'll subtract and solve for this one, and we can clearly see x cannot be 0 or -2, which creates an issue with one of our answers. We have x equals -2, but that's a restriction. So that is actually not an answer. My answer is x equals -1, where x cannot be 0 or -2. And that is how we solve rational expressions. In our next video, we are going to go over more complicated rational expressions with binomials and a lot more factoring involved. In this situation, this is the gist on how to start going about it, especially using this method of using the least common denominator to cancel denominators and just turn it into a basic algebra equation. If you have any questions, please ask in the comments, and I'm more than happy to make another video and help out. Hope everyone has a great day.